4.2 atoms. Key ideas in this section. What is the difference between protons, neutrons, and electrons? What do atoms of an element have in common with other atoms of the same element? And why do isotopes of the same element have different atomic masses? What unit is used to express atomic mass? So, what is the difference between protons, neutrons, and electrons? The three main subatomic particles, so the three main pieces that are inside of an atom, are distinguished by their mass, their charge, and where they're located in the atom. And so the three main subatomic particles are protons, neutrons, and electrons. Protons have a positive charge. They have a mass of 1.67 times 10 to the negative 27th, and they're located in the nucleus. Neutrons have a neutral charge, a charge of 0, and their mass is the same as protons. They're also located in the nucleus. And then electrons have a negative charge, and their mass is a lot smaller. It's 1,000 times less than the other two, and they're located outside of the nucleus. Each element has a unique number of protons. So that is the number of protons is what makes each element what it is. Carbon has 6 protons, and no other element has 6 protons. Nitrogen has 5 protons, and no other element has 5. Unreacted atoms have no overall charge, and so in normal circumstances, atoms are neutral. And that means that they have an equal number of protons and electrons, so their charges cancel out. The electric force holds the atom together. So because we have these positives and negatives, the positive protons are attracted to the negative electrons by electric force, and all of that holds the atom together. So atoms of each element have the same number of protons, but they can have different numbers of neutrons. So carbon has 6 protons, but there are different forms of carbon. And so there are forms of carbon that have 6 neutrons, there's forms of carbon that have 7 neutrons, and there's forms of carbon that have 8 neutrons. So when you're looking at the periodic table, there's going to be 2 main numbers that you're going to need to know what they mean. First is the atomic number. The atomic number is generally the number that's going to be on top of the square in the periodic table, and it represents the number of protons that are in that atom or that element. The other number you're going to see on the periodic table is the mass number, and the mass number is the total number of subatomic particles in the nucleus. So it's how many protons plus neutrons are in the atom. So if this was a nucleus of a certain atom, then its atomic number would be equal to just the number of red dots, or the number of protons, and then its mass number would be everything that's in the atom. So the different elements can have different numbers of neutrons within that element. Like we said, carbon, it has 6 protons, but it could have, some versions have 6, some versions have 7, some versions have 8 numbers of neutrons. And those different versions are called isotopes. Isotopes of an element vary or are different in mass because their numbers of neutrons are different. And so these are 3 isotopes of hydrogen. And so notice what's the same between all these. First off, there's only 1 red dot in each of these. And so that means there's only 1 proton in each of these. And so hydrogen has 1 proton. Every type of hydrogen has 1 proton. The other thing to see is that they all have 1 electron. And so they're similar in that way. But they do differ, because this isotope of hydrogen is called protium. It doesn't have any neutrons. This isotope of hydrogen is called deuterium, and it has 1 neutron. And then this one is called tritium, and it has 2 neutrons. Some isotopes are more common than others. A radioisotope is one that's unstable and it emits radiation as it decays. And so, because some isotopes are more common, we can calculate the number of neutrons by doing mass number minus atomic number. And we will work with this for several days. We'll practice this by looking at the periodic table and figuring out, based on the mass numbers, how many neutrons, protons, and electrons something has. But just for introducing you to it, so this is chlorine, 2 versions of chlorine. Chlorine has 17 protons always, and so its atomic number is always going to be 17. But there's 2 different isotopes that we're looking at here for chlorine, and so chlorine's mass number here is 35. And so to find the number of neutrons, you would do mass number minus atomic number. I always say man. Mass minus atomic equals neutrons. And so you're going to do 35 minus 17 gives you 18 neutrons for this version. This other version has 37 for its mass number. So you do 37 minus 17 gives you 20 neutrons. Because we're working with very tiny masses and working with such tiny masses is difficult, atomic mass is usually expressed in atomic mass units, or AMU. And a 1 unified atomic mass unit is a unit of mass that describes the mass of an atom or molecule. It is equal to exactly 1/12 of the mass of a carbon atom with a mass number of 12. Basically, it's just this unit that has been made up to be able to help us to work with these atomic masses in like whole numbers instead of all these scientific notation numbers. Average atomic mass is a weighted average, and so that's going to be the number you see on the periodic table, and it is going to have a decimal generally, and that is because it's an average. So isotope abundance determines the average atomic mass. For example, chlorine 35 has 76% abundant, and chlorine 37 is only 24%. That means 76% of the time, if you have a sample of chlorine, it's going to be chlorine 35. 24% of the time, if you have a sample of chlorine, it might be chlorine 37. But using some math and things, you can calculate the average atomic mass, and it will come out to 35.453. Another unit that we use is called the mole, and it's useful for counting small particles. A mole is the SI base unit used to measure the amount of a substance whose number of particles is the same as the number of atoms of carbon in exactly 12 grams of carbon-12. It's a very large number, so a mole is 6.02 times 10 to the 23rd, and it's called Avogadro's number. Moles and grams are related. Molar mass is the mass in grams of 1 mole of a substance. For example, 1 mole of carbon-12 has a mass of 12 grams, so the molar mass of carbon-12 is 12 grams per mole. And we can convert back and forth between moles and grams using some different formulas. Now, we won't be doing this very much, but you do need to know what molar mass is. Compounds also have molar masses, and so you can add up the molar mass of all the atoms in a molecule for the molar mass of the compound. So like hydrogen or H2O, 2 hydrogens and 1 oxygen, you would find the molar mass of oxygen is 16, molar mass of hydrogen is 1.01, and then add all of that up. So 2 hydrogens and 1 oxygen added up, you would have a total of 18.02 grams per mole.